but I thought it'd be good to spend some time just looking at Poutyne. So, right here, Poutyne.org. We've already installed it. It was so easy to install last time, just a pip install. Once you already have PyTorch, of course. PyTorch in general, less painful to install than TensorFlow, so points in their favor. What I want to find is there an existing tutorial? If there's not, we're going to see what we can do. And that's going to be the way it is. I have opened a couple of their pages. They also, of course, are up on GitHub, Poutyne. You can look at all the code, do all these kind of things. They have Get Started. That's something, actually. That's certainly not nothing. Do they have a more extended? They have a couple examples. Tutorial version. Hey, there we go. Interesting. PyTorch Poutyne. Comparison of Poutyne with bare PyTorch, an example of a Poutyne callback. Well, we're not going to be fussing around with that too much, but again, what I don't want to do is just copy-paste. I want to make sure I understand what the heck is going on. I don't want to do all this nonsense. Loading DanDoesData. Why do you load DanDoesData? I just said, I don't want to just copy-paste, but we're going to copy-paste a little bit. It's going to happen. It's going to happen. If you recall from last week, PyTorch, what was it called? Try PT? That's probably what it was called. Poutyne. Nope, not there. If you recall from last time, we took a look at this. PyTorch 1.4. There it is. Where is it? Is it not here? Poutyne. I could have sworn there we go. Yes. We made some random hot garbage to futz around with whatever we were futzing around with. Why don't we do this stupid MNIST thing? Here's what we're going to do. We're going to load up, or we could try to recreate what we did a few weeks ago with the MNIST mash. Come on, where is it? Nope, that's not right. Alright, let me just find this project. MNIST, no? MNIST, no. Alright, where is it? Digits, of course. That's where it is. Digits. And digits data, digits model. There we go. So here's a Keras model. We want to do something similar, but not exactly the same. This will be a way we can learn what the heck it is that we're doing. Let me grab some of this code. Right, yeah. We might still use Keras to read in the data. I don't know if Poutyne can do that for us. Let's find out. Let's do this. I don't need that many copies of NumPy. There we go. Import Poutyne as PT. So no torch involved at all directly. So let's see what happens. Is there a way to just read the data with that, or they use... And their official things, it looks like they're using the MNIST that's available with Torch. Torch isn't that data set's that MNIST. Which is cool that it comes straight with Torch, and probably comes with TensorFlow as well. But can I just look at dataset framework, blah, 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 utils? What kind of utils do you have, actually? I am curious. Oh, it's a module, okay. So like a 2 categorical, Torch 2, Torch to NumPy, NumPy to Torch, set C, it's not really anything particular. Okay. No worries. And I can't get my hands on model in here. Oh, that's part of framework. I see. There's no but I can't. Okay, I can. Oh, jeez. Bunch of stuff here. Is there like a sequential model similar to... Oh my goodness. Model checkpoint, configuration, NumPy to Torch, periodic, all this other stuff. There's not a sequential. Alright, that's fine. Anyway, I'm going to keep using the data I've already rolled here, so I don't have to futz around with this other stuff. Let us then... We're just going to comment out all this stuff. We don't need that. This other stuff, though, we're going to need. Get some metrics, get some matplotlib. It's going to be a good time. Read in our data. Well, that's not where the data lives, though. Data lives in /digits/ close call. That should be fine, then. Data is not defined. Nope. Didn't get my data. Why not? NumPy is not defined. Could have sworn I did that, but I guess not. There we go. Much better. Our training images, our validation images, all this nonsense. Cool, cool, cool. Now, how did we use this model? That's a bunch of random data they're making. Oh, it's right here. I just blitzed right past it. They convert a model, a PyTorch network, into a model object. That's how I used it before. That's not how I want to use it today. Today, I want to use it to like make the model directly. Okay, is that a thing I can do, Poutyne? Because that's going to be the determinator of if I want to continue using this. Training the Poutyne way. Create fully connected network. What? Create a Poutyne model. Oh, okay. You're making a little thing. I see. Poutyne callbacks. Making your own callback. Poutyne experiment. Experiment train. None of that is really what I'm looking for. Something simple. No. It's still not what I'm looking for. Like, I appreciate this. You know, it's just a simple linear model. But I want to sort of like the Keras model.add or like I said, it'd be sequential.add, I guess. Is that a thing we can do? If not, I'll be a little bit annoyed. Transfer learning, policy sci-far. What can I do with model, actually? That's a dumb. What can you do with model? Network. A PyTorch network. Can I not just build up a network with straight Poutyne? I mean, it's not the end of the world to do it with PyTorch, right? Like, obviously, we did that last week. We just did this thing, right? It's not that bad. It can be done. In fact, this is already pretty Keras-like to begin with. But if I can just do it all in Poutyne, my life will be a little bit better. Here's Poutyne model. Model argument attribute is deprecated as a version 0.6. Use network instead. Interesting. So you have to submit a PyTorch network. What about experiment? Class is still in beta phase. That's fine. Path to experiments. Oh, this is like to futz around, fine-tuning whole network training procedure, but not like the network itself. Okay. Layers. Applies a function to the input tensor. Poutyne provides utility layers to be used with the sequential module, module list, and others. Okay. Okay, so it does not have the Keras-like feature of having the model object, and then I just add things with the model here and there. That's fine, because Torch has some of that. This means we're going to need to grab Torch stuff. So let me do that. We will grab import Torch as tr, because again, I like two-letter names for things that I use all the time. Don't need any of this stuff. What I do want is this model function. Let me grab all this, because I'm going to need it. Here we go. And then somewhere we call it a PyTorch network. So we'll need to convert what our thing into like a PyTorch network. Whatever our model object is, which maybe that's already a... Let me start here. I don't actually care what it is. What is D? Here we go. Also, I don't want to call this torch. I want to call this tr. tr. Yeah, here we go. tr.nn.linear. Can I inspect this? Applies linear transformation, incoming data, math equals this. In features, out features. Okay. Size of each input sample, size of each output sample. So in Keras, it's really convenient. You don't need to track all this nonsense, this input features. You only track how many things do I computing out. It'll do the math on the rest. Super convenient. A little irritated that that's not. Actually, is there a way to just say that's figured out now? Shape inputs, where math means any number of additional dimensions, and NHN. NH out. We're all the last dimension of the same shape. Alright, so it's like the number of channels still, but you got to keep track of this information. Which just grinds my gears a little bit. Because like now I have to look at my data, I'm like, alright, what is it? What shape is it? This whatever nonsense dot 28 times 28. But of course, I'm gonna unroll that all into a 784, 28 squared. Yeah, 784. We'll unroll all that, just for the purposes of the stupid linear model. So how many things are coming in? And I just stared at this. Is that really in features? Size of each input sample. Shape. N star H in. Means any features of whatever. Okay. So if I put in a specific number, like 784, and I want to spit out, I don't know, 10. Just work with me here. Is that a thing that I can do? Does that choke? Torch? In features, out features, bias true. Whereas if I did, I don't know, 10, 2, I don't know, whatever this is. Size must be tuple events, but found element type tuple at position 2. Argument size must be tuple element of type tuple at position 2. That's curious. Must be tuple events, but found an element of type tuple. Yes, it is a tuple. Amazing. That could get irritating in the future. I'm gonna choose not to worry about that right now. So you can make a thing. This is my linear layer here. Applies linear transformation incoming data, yada yada yada. What about torch? Is this a network object? Sequential container. Modules will be added to it. Da, 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 da. Here's a small example. Convolution 2D stuff. You can name it with the dictionary. I don't really need to care about all that nonsense. Okay, well, tell you what. Let's just do this. Obviously I want 10 things here, and I want 10 things on the out. Just hear me out here, pal. Can I do a softmax? Dot soft. Ugh. What are my options here? Do I not get to see any options? No? Apparently not. tr.nn. That's okay, there we go. There's all the things. Softmax was one of the options. Why did it not tab complete? Not soft. There we go. Softmax. There's Softmax 2D. Is that any different? Features to each spatial location. Interesting. So it's like a fully convolutional thing. I mean, you can already do that, but... Alright, cool. Softmax. And tell me that this works this way. With a capital M, of course. Did I not... Was I not just looking at this? I swear I was just looking at this. Softmax. tr.nn. I'm losing my mind. TITF. Oh boy. One of these days. One of these days, folks. Applies the function to n-dimensional input tensor, rescaling them so the elements of the n-dimensional output tensor lie in the range. Oh! Interesting. So it takes in like your output logits and then does the calculation. So I have in fact done something that's vaguely correct here with this construction. But I can't just say, man, throw a softmax on the end and there's this many input dimensions and this many output dimensions, which is miserable. But oh well. So not ideal, but that's a Torch problem. That's not Poutyne's fault. That's just the way Torch is, I guess. And it takes from 1 to 2 visual arguments, so 3 were given. How did I use this here? No, I definitely did it here. Right? If I were to just import Torch. What is going on? Oh, do I need to turn off auto? I need to turn off auto indent first of all. Hang on. That is grinding my gears there. That's cute. Poutyne. Did something change about how they use it? No, I ain't doing that nonsense. Torch sequential. Torch sequential. Here we go. I thought their whole deal was just like, give me as many arguments as you want. Why is this not working then? And it takes from 1 to 2. Oh, softmax it doesn't like. Right, okay, so that's softmax's fault. Because softmax is weird. Assume same in as out. There we go, okay. Kind of thing is a model, it's just like, you know, okay, cute. I like that, but type. So here is a question I have. Do all this nonsense, whatever. Oh, not torch. TR. Because I ain't typing that much. Here we go. And again, this is all just silly torch stuff. But if the training can work in Poutyne, that'll, you know, save me some headache. Poutyne down here, these 2 lines, that's what I need. And instead of PyTorch network, what if I say model? And yeah, what if I keep these things, whatever. Cross entropy, can I do categorical cross entropy? That's what I would like. And clearly this is applying its own object, or its own, excuse me, optimizer. What does that take? Optimizer, loss function. He put his name in a prediction. PyTorch launch function. Blah 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 blah. Okay. Let's see if we can do this. If not, oh, what's that? Categorical cross entropy. Oh, key error. Categorical cross entropy. Well, that's not the key I put in. I have. Yeah. Okay. Fine. What is the torch name for categorical cross entropy? Categorical. Oh boy, now this page search cross entropy. No, really? None? Cross entropy. Cross entropy loss. Precise model attributes, blah 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 blah. Combines log sub and log in loss. Yes, yes, I understand this. Over all J, okay. Okay, so just cross entropy loss. So none of that. Let's see about that. Okay, that seemed to do something. That's good. Got a Poutyne going right there. Oh yeah. Not a copy, that's terrible. Oh. I'm gonna get burned on that so bad in the near future, I'm sure. Oh, I've done something terrible. I should call this like network. And this like network. There we go, let's do that. How did it decide the learning rate, I wonder? Okay, got that. And then what am I training on? We are training on training images dot reshape. Reshape. -1784. We are training on outputs. That is what it is. T labels, right? Yes. We are having validation data, which is v image dot reshape of 1784, and validated just becomes v image. Epics, not even. Alright, let's see if this works. Expected object is scalar type float, but got scalar type byte. Really? Really, that's what we're going to complain about today? Because those are UA8s. Fine. Fine. Change it all to floats. Change into floats. It's something Keras handles just fine. Equals floats. Eat up some more memory over here. Do that over here too, I suppose. T-type equals float. And we're going to do the similar kind of thing over here to our validation data as well. And yes, I'm just doing this all right here, but really you would probably want to do this outside of this little function. so you're not constantly having to rebuild it. I don't want vimage, I want vlab. So good thing I caught that. D-type equals float. I don't want those, none of this nonsense. Da, 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 da. Okay. No more excuses about that. Expected object with scalar type float, but got scalar type double. Ah, oh, come on. Really? Really? Can I just say float 32? Is that a thing I can do? It is. See, NumPy, super good. Other things, not so much. This kind of brittleness irritates me. But still, pretty cool that Torch can just, it has this simple format here that I don't think TensorFlow has, because TensorFlow has keras, you don't really need that. Alright. Dimension out of range. Expect to be in range of -2, 1, but got 10. What? Is this a problem with categorical cross entropy? Let's, rather than search torch pages, let's ask the internet. Categorical cross entropy, torch, PyTorch, PyTorch. Sure, whatever. What is the appropriate, yeah, here we go. PyTorch equivalent of this. Da, 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 da. Someone has a model. Someone has an unhelpful comment. And no one has an answer. From 2 years ago, almost a year and a half. PyTorch, come on, PyTorch. Cross entropy loss, da 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 da. BC with logits loss. Doesn't quite do what you want to do. Da, 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 da. If I'm missing something obvious, you know, absolutely help me out. Why? There's so many ways to view cross entropy. Good question. Related to softmax, da 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 da, other nonsense. This is a little irritating. I didn't expect PyTorch to be this obtuse. No, don't continue with anyone. Jeez, oh man. Torch. Categorical. Why, you know, Google, when I ask for categorical cross entropy, I expect to receive results about categorical cross entropy. It's not that difficult to show me those results. Make specific elements and final layer, yada yada. Binary cross, okay. Now is this a PyTorch? Yes. Softmax top 2 is mathematically including a single, yes. Let's see, what is that? Yes. Okay, so you are not answering the question that I have. Why is this such a pain? I feel like this is almost certainly what the problem is. Because with binary cross entropy, you expect there to be one number at the end. What is the probability that this is a thing? Well, when I have a bunch of things, like this shouldn't be this complicated. Torch, softmax, cross entropy. Again, here's your official multi-class cross entropy loss function. Yes. It's called categorical cross entropy. Where is it? You could try the following code. Why would you do this? Why do you not just have one? Is the softmax applying logits? Still not explicit, blah, 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 blah. Of increased risk of overflow. So you claim this business. You should use under nn.cross entropy laws, which takes pre-softmatch logits. Sure, whatever. We don't really care. That's not a big deal. Or use log softmax layer and feed that into NLLL loss. LLL loss. Should run the probabilities outputs through log. Yeah. Single PyTorch cross entropy takes post softmax. That's insane. Yeah, I mean, people are going to want to just compute the answer. I don't know why every library I look at, there's always something missing. Always something missing. Categorical. Tell you what. Can cross entropy be one word? Yes, no, maybe? What if it's 2 words? Binary cross entropy. Oh, so maybe you just want it on the logis itself. Cross entropy. Okay. See, cross entropy loss details. Combines log soft. Oh my god. Why do you make life so complicated? So maybe you don't want the softmax at all. You're just gonna run on the. That's insane. Insane, frankly. Let's sure. Let's not put a softmax on. Because that makes sense. But when I'm going to want to predict the Gorian probabilities, it's not going to come out of my network. I'll add a little bit more extra stuff. Which is just irritating. I shouldn't have to do that. Should not have to do that. What if I said... Hang on. Cross entropy loss. And then log softmax. Training classification model with C classes. The optional argument weight should be a 1D tensor. Assigning weight to each of the classes. Yeah. You have an example right here? You do, okay. Make some torch nonsense. Empty loss. Input target. Don't name your variable input. It's a keyword in Python. Do not do that. This is a criminal thing to do. What are you doing here? This is your loss function. You just say make this from here to here. Okay. Bunch of empties and a bunch of stuff here. I'd like to be able to just use a name. And if is cross entropy loss the correct name, but to sort that out, I need to know. Any PyTorch loss layer custom loss function can also be a string with the same name as a PyTorch loss function, either the functional or object name. Loss function much have a signature, whatever. So, cross entropy loss versus cross underscore entropy. I don't know. Cross entropy loss? Or, is this what I want? I think that's what I want. Cross entropy loss. Let's try that. Cross entropy loss. And then log softmax. Yeah, you don't show it to me in a model, though, which is irritating. These are points against PyTorch, but a point against PyTorch is unfortunately also a point against Poutyne, unless Poutyne specifically addresses that, which I'm not seeing in this model. Come on. Let's come back up here, do this nonsense. Come over here, do this. Okay. Is there like a summary thing? No? Save weights? Okay, well that's something. CPU, what is CUDA about? Transfers network to the GPU. Ooh, shouldn't that be default, pal? Interesting. Okay, now let's try training it. 1D target tensor expected, multi-target not supported. But this is a one-dimensional. Input target weight reduction. Do I not do this? Do this instead? No. 1D target tensor expected. Okay, let's try to figure this out. Again, these are all just torch problems, but a torch is going to be weird. Torch tutorial. Just show me your stupid in this tutorial. You have to compute multiple things there, so. Or sci-fi, whatever, who cares? And so help me if you just have a model that's one line from something else. Make grid, yada, that's all fine. You define your network. You do a bunch of things with linear layers, that's great. Do a bunch of convolutions, do a bunch of linear things, who cares? Make the computations, a bunch of ReLUs. Define a loss function. Cross entropy loss. There. Right there. Then you train the network. So I ought to be able to just use cross entropy loss. You are spitting out 10 things. 10 things. I'm not spitting out any softmax nonsense. 10 things. 10 things. Unless my loss needs to be against something different now. Right. What do your labels look like? Are your labels the numbers themselves? That'd be some weird data iter. You don't show me what the labels look like, do you? No, you don't. You don't. Classic mistake. Oh, you show me what they look like. You don't show me what the numbers are, though. That is classic mistake. Train the network. Labels. See if we can quickly understand what's going on here with labels. As we're halfway through it, we haven't really gotten to do much Poutyne. It's very frustrating. Labels of J. Classes where J is a particular image number. Print space dot join. This is you stuffing it in the class, like you're printing the object itself. No, it's image set. Oh, the actual name. Deer, frog, bird, cock. So these must be integers. I see. I see. I see. I see. You don't want one-hot things. Is there a way to do this? Not one. Is there a way to do this if I have things one-hot encoded? Is that cross entropy? Is that this? Cross underscore entropy, maybe? Maybe? Or do I have to do it this way? Be a little bit annoying if I had to do it this way. Let's see if we do this. See if that works. No. Okay, that does not work. You have to do it unless you define your own custom loss function. I'll have to convert my labels back to integer encoding. Alright, fine. TT lab is fine. This will fix up our stuff here while we're in the neighborhood. This is going to be, I want, show me the biggest one, everything in T-lab along the last axis, right? Let's just check it over here. T-lab, right, which one has the 1, essentially? Yes. This should be as long as all the data points I have, cool. Of course I gotta say, you know, float 32 over here. Alright, and BB labels. There we go. Shove these in. TT lab, and of course, over here, BB lab. Now then, let's see if that works. Expected scalar type long, but found float. Okay, fine. So help me. I'll make the mints. There it goes. Okay. Accuracy 0%. It's a turbo model. Of course the accuracy is 0%. Oh, it's a dumb linear model. The accuracy should not be 0%. It should be something. I just realized a problem. This data, you're trying to predict 2 numbers on the output. I really am trying to predict 10 probabilities in the end. So I probably do want 10 softmax-like things. What did I do in my Keras model? Model.fit. But yeah, 10 times binary cross entropy is what I did. Whoops. Well, you know, my brain was on MNIST. Okay, but that ran. It did a thing. Loss is always the same, though. It clearly didn't move anywhere or do anything of interest. But we have it. These numbers, how much time it took changed, but not any of the loss functions. And it's exactly the same. Well, that's not exactly the same, is it? Hang on. Hist of 0. Hist of 0 of loss. Well, that's actually different. Versus val loss. But if I look at 1, that's the same number. And if I look at 1 of loss, that's the same number. You know, this model's definitely horribly broken. Let's see if we can fix it. And this will probably determine, like, how much do I want to use PyTorch in the future? If I can get Poutyne to do these things for me. Right now, it might just be I'm more familiar with Keras, but I'm also at the point in my life where I don't need to learn every new tool. If I have a tool that works pretty well, I'm just going to use that. I'm not going to save that much time by using a different tool. It might change how I approach problems, but once you already have a good set of tools, you don't need to keep getting new tools. Alright. This loss function is hosed. I wanted to check out the binary cross entropy. Binary cross entropy with logits. Function that measures binary cross entropy of the target and the output. Tensor of arbitrary shape, target the same shape as input, yada 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 yada. It's not a very fully formed example there. Cross entropy between target and output of logits. EC with logits loss for details. Let's see if that loads. I get annoyed that this opens up the page and then drags it down. Sigmoid layer with BC loss into a single class. Order stable using the plain sigmoid followed by BC loss. Did I do? I did do sigmoid at the end here, didn't I? Iteration sigmoid. I'm a dumbass. Stupid. Combine sigmoid layer with a BC loss in one single class. Alright, but I want to produce like 10 numbers at the end. Okay, that's something I can do here? Maybe not. Let's find out. Let's find out. I want to know what happens when I do this. I don't want... This is clearly... This, I don't think, did what I wanted. Right. So let's do this. Grab that again. And just run this again. Let's see what happens here. Target element must have the same number of elements. Target n element equals 32. Input n element equals 320. So clearly you're giving me 32 things in the batch size, the target. The input element, like what we've computed, is of course 10 things for every point. But, hang on. Also, this is still wrong, right? Because like I want to compute 10 things. Shoot. Fine. We will do ft_lab. NumPy.array of tlab dtype equals float 32. I'd probably have to put things back in like this, so that's the expected shape. So float tlab and float validation labels. Let's see how that goes. Size of tensor must match a tensor B at its non-singleton dimension 1. Again, that's grinding my gears here. Torch. Like label prediction. Training a classifier, sure. We'll go back to here. No, I already had that open. Over here. Test the network concept. Test data. Cat chip plane. Chip. Cute. Load state torch. Again, predicted I. You're predicting a specific class. Those torch.max outputs and which axis you're going on. Literally have 10 things. No, not torch label prediction. Torch tag prediction. That's probably what I want. Sequence tagging. It's a little bit more. Maybe multi-label is more what I'm looking for. Multi-label classification problem. Is this a torch thing? I've used cross-entropy loss before in a single estimation. I would calculate the accuracy like this. And then, oh, multi-label soft margin. What is multi-label soft margin loss? Multi-label margin loss? What is this? I've never heard of this. Never heard of this. Multi-label margin loss. What kind of loss is better to use in multi-label classification? What? Blah, 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 blah. Multi-label soft margin loss. You know, I just wanted to see what that line was. Dot multi-label margin loss. Tell me about this. Optimizes multi-classification hinge loss. Okay. Margin-based loss between input, a 2D many-match tensor, and output, which is a 2D tensor of target class indices. Hang on. Criterion only considers a continuous block of non-negative targets, so is it not in the one-hot style here? You know, several years ago I used to hate one-hots. Clearly I've come around to the other side, and now that they're doing the opposite here, it's going to drive me a little crazy. Float tensor. Multi-label margin loss. These are a bunch of probabilities for each class. Only consider labels 3 and 0, not after label -1. What? Why would you... What? Why would you store this in this way? So you're taking 0.1, 0.8. What is this ridiculous nonsense? Oh boy. Anyway. Take the number 3, which is 0, 1, 2, 3, 0.8. You subtract 0.2, you subtract 0.4. 0.1 minus 0.4, 0.1. I just clearly am not familiar with this loss super much. What about soft margin loss? Yeah, soft. Maybe that makes more sense. 1 versus all loss. Okay, maybe that's more what I'm looking at here. They don't have an example, which is again grinding my gears. Multi-label 1 versus all loss based on max entropy between input max x and target math y of size n comma c. Where n is the c's number of classes. Yeah. 1 over c times. See how good I can read my LaTeX right here. Take the sum of whatever yi is times log of the other thing. I think this is what I want. Alright, let's see if we can use that. Drive ourselves insane here. Multi-label soft margin loss. Multi-label soft margin loss. Let's see if that works. Well, it does. I don't even know. Alright, can this run? Nope. You're expecting... What should I size tensor B at non-singleton dimension 1? You're still expecting one number in each position, which drives me nuts. What if I just did this? What happens then? Just... What happens? Expect scalar along, but found float. Right, because you expect... What was this nonsense? There's some insano... Right, not even over there. That, margin multi... Multi-head attention, multi-head margin loss. Multi-margin loss, multi-label. There we go. Yeah, this is not a label I'm familiar with. It's multi-margin loss. Multi-label margin loss. Multi-label soft margin loss. What is that thing? For example, you have 1 of 10 possible classes. You should be using cross-entropy loss. I don't. I have n of 10. You seem to be thinking the counterproduct goes into BCE loss. 2/more labels in the universe. Thought BCE loss was way too many tabs open here. Ugh, come on, Torch. The target and the object. I thought I did BCE loss. Target and the outputs. This doesn't do anything fancy. This just measures direct. Let's try BCE loss, you know? BCE loss. No, it still doesn't like it. It doesn't let me do 10 things at once like Keras does. It is not as powerful, it seems. They seem to just not have as many loss functions as I would like. Multi-label margin loss. Multi-class multiplication loss between X and Y. 2D tensor of target class indices. That's insane. This is the weirdest thing. Not after label -1. So I would need to pull out all indices that have a 1 and move them back to the center. Alright, let me see if I can do that. We'll try this multi-label margin loss again. Okay. So this will give me the first index that's successful. Because I know I only ever have 2, what I can do is do like the reverse. Oh gosh. What I want is to have this in the reversed order. Right. Can I flip? Reverse the order of elements in an array along the given axis. Yes. So, T-label looks like this, right? Cool. I flip it. Now it looks like that. This is now here. That's what I need. Okay. Now we got flip. And we're flipping axis equals 1. And as well over here. This will find us our 2 points. Axis equals -1. Okay, because now TT lab and RT lab, those are the 2 things that we have. So then we just get n1s equals nuns. That's funny. Numpy.1s, excuse me. Is there ones like? Oh, there is. Oh, cool. Okay. I knew that was a thing in TensorFlow. I didn't know it was in NumPy as well. Super good. T-nuns. T-1s. So I'm going to say -1 times this. And we do the same thing with the validation data set, right? And what we're going to do is stack them up. TT lab, not that way. RT lab, T nuns, and ones like TT lab. That is what we're gonna do. And we'll say these are my, my torch T labs. Put that in there. Be good like that. Okay. I got my RT, my whatever. Yes. Do this stuff. Do this. Only parade as much as seems to be. I'm pretty sure they do, actually. Pretty sure they do. Yeah. TTLab.shape. RTLab.shape. Tnuns.shape. Oh. Arrow. TVV, there we go. So now we have what we want. I just need to transpose this, and we'll be good to go. Bam, look at that. Now, this looks like their Insano dataset. Great. Except, I need more. Right, I need 10 things in here. I think I want 10 things. I'm pretty sure I want 10. Pretty sure we want 10 things. So, hang on. Do this plus this for I in range 7. 7 copies. Cool. And then we'll change this to torch VLab. That's VVLab, that's RVLab, and this will be VVLab. Do that. Inlet arrays must be the same shape. I'm not happy about something here. Did I not redo this? Oh, I put T-nuns in there. I need V-nuns, of course. Apologize, my voice is starting to give out a little bit. Okay. Now we got that. Now maybe, this multi-label margin loss, we can get the answer. Let's see what happens. We're not putting in this anymore. Now we're putting in the torch labels. And we're putting in the torch validation labels. Torch VLab. There we go. Inconsistent size for argument number 2 target. Really? Wait. What? It looks like 4. What? 32,4. Oh, did I not rebuild this? Same problem. Must match size. It's expecting only 1 output. Here, you've clearly generated 4 things. And so you put in 4 things as your target tensor. So it's like you have 4 tags you're trying to apply. Not after label 1. For target Y, only consider labels 3 and 0, not after label -1. This is just an insane way to store your data, right? Like, this is a perfect place to just use 1 hot encoding. You'll be much more sane. Put a 1 in those locations rather than, is 3 0 different than 0 3? Like, why? Why do this to yourself? I mean, Poutyne has some nice features, but I think it's just hobbled by Torch in a lot of ways. Torch just does some things very differently, it seems, which is making me dislike it, which is unfortunate because TensorFlow had been annoying me, and I thought, well, maybe I'll just switch to Torch. Maybe everything is annoying. Maybe I'll switch to Cafe next. Although I tried that once and it was not a good time. Or, TensorFlow 2.2, significantly better than the alternatives. This is... I'm not sure what to do with this now. Multi-label margin loss. Soft margin loss? Is that what you want now? I don't think so, but we will try it. No. Size of tensor must match size of tensor. Tell you what, let's search that function, that error. Get rid of all this nonsense. Size of tensor must match. Yeah, blah, 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 at non-singleton. Singleton, yeah, whatever, that's fine. You get the idea. People having a problem. Blah, 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 you're doing some sort of torch thing. You get this problem. For all operations, you need a better idea how tensor shape changes with each operation. well, is there an easy way to do that? You know, if I have this network object, network, out features, relu, there ought to be 10 features out for every single input. So we were able to make a train once with some arcane incantation that's now lost to this world. Yeah, I feel at this point I'm fighting the library more than it's helping me solve a problem. And until I see, like, I don't know, Poutyne tutorial, like, obviously, yes, there's this little thing, but this, it's not exactly what I wanted. Loss function not in there. Cross, no. What are you doing if loss function is not in here? The phrase loss is just not in here. What are you actually doing? Here's your wacky convolutional neural network. You're gonna make it. I think this might still be under construction. That's part of the problem. Cross entropy loss with. I know I searched for cross. I heard lies. Making your own callback. And then cross entropy loss. See, like all this object oriented. That's not what I want to deal with. Yeah. Okay. They're still working on things then. Maybe Poutyne just isn't really ready yet, which is okay. I still like to give it. I was glad I could give it a try. But yeah, I'd love for this to be able to. I understand what I'm doing is not trivial, but it's also not rocket science. It's not that complicated what we're trying to do. I do appreciate having a model that fit, but again, this is just a torch problem. Of its set of available loss functions is just weird, and how they work is weird and not like my brain works. So that is the problem there. Multi-label soft margin loss. Which is like, I swear I've seen this 100 times. Print is 10 for gold then. Dice loss for multi-class prediction, flying prediction, yield size mismatch. 100. I don't understand how to use this approach. Trying to predict 3 different classes, yada yada yada. The problem is people ask terrible questions and don't. Before load, wait to reshape the weight first. Ugh. This is terrible. Fast AI. Size of tensor muscle. This one looks right. They're doing a thing. You down at the bottom. Mean normalized. Yes, but how do I construct the loss function to do what I want? That's what I'm not seeing. BCE loss. BCE with load its loss. Combines a sigmoid and BCE loss in one single class. More numerically stable. Do I want BCE with Logit's loss? BCE with Logit's loss. Is it a thing that exists? It is. That's pretty cool. That anything that exists right there just works. Float can't be cast at a desired output type long. Great. Oh, once again, that's expecting. No, hang on. Result type float cannot be cast at desired output type long. Really? Why not? Just. Wait, what? That combines a sigmoid layer with the BCE loss. So my output of the model should not be a long. You're insane. That makes no sense. Binary cross entropy Logits. Alright. Well, we spent an hour futzing around with this. Poutyne has some cool features if you have a working PyTorch network. If you have a working network. then yes, you can just use Poutyne to say model.fit, do the thing, and your life will be good. The problem is getting a working network is really painful. You can't do that in Poutyne. You have to use the PyTorch implementation itself, and it has some weird opinions about where to insert loss functions. And like, well, I'll just use the last output layer and make it part of my loss function. Like, I get why you want to do that for numerical reasons. I get that. Numerical stability. But I'm trying to do something not crazy, that in Keras was not hard at all, and relatively easy to understand. And Torch is just making it seem impossible. So, until Poutyne can work around these weird issues with Torch, and until Torch stops being weird about this, which I don't think it's going to, because if you prefer this syntax, there's already a thing that exists for that. It's called, TensorFlow. It's called Keras. So, Torch is clearly working with a different market, a different population of people who want different answers. Poutyne is trying to bridge that a little bit. And again, if you have a Torch model that already works, Poutyne works great. Just make your Poutyne model out of that. I assume you can pass in an actual optimizer object and all this other stuff. And then just call model.fit. And that'll save you a lot of headache. It certainly made this a lot nicer last week. But Torch is a pain. I decided I don't really like Torch. I wanted to like it. It has some weird opinions that I don't like and I disagree with. I spent a reasonable amount of time trying to understand what's going on here, and it's just not working out, Torch. Why is categorical cross entropy not even on this list? Even if you have strong opinions about it, you should just provide that. And you can put a big warning on it. Be like, hey, numerical instability problems. Grinds my gears. Alright, that is all I got for tonight. Thanks everybody for coming to watch it out. I don't know what we're going to get up to next week, but we'll keep on streaming. As always, stay safe in the data mines.